So, really appreciate the opportunity, Julie and Henry and Ryan, pulling together this workshop on, I think what is a very interesting and especially nascent topic for, our industry and especially for the Corps of Engineers. So myself, I'm Robert Moser. I'm a senior researcher here at the Engineer Research and Development Center. We're the R&D arm of the Army Corps of Engineers, but really support across the DoD a lot of the research and technology development activities in all things infrastructure and the environment. I'm also joined by my colleague, Eric Kreiger, who leads our Additive Construction program, which has garnered a good bit of interest, and I know Henry and the team was especially interested in when we talk about optimizing design. And so he's going to speak to this as well, and he comes out of our Construction Engineering Research Laboratory. So I'm going to flip through and just give you a little perspective on some of the things that we're thinking about, some of the activities that we've got going on, both in support of the Corps and more broadly with our interagency partners and non-federal sponsors, local communities and states, as well as some of the directions that we see going in the future, particularly with some of the new drivers from this new administration. So just to highlight some of the work that we do, I said all things infrastructure and the environment. You can see some of the research and development thrust areas and competencies that we work in here at ERDIC, just as background. I'm not going to beleaguer on these marketing charts. But that all plays into the types of material technologies and manufacturing sciences that we're working towards. We're largely focused on application-centric performance for military applications, but when we also think about our installations, environmental quality and infrastructure systems, some of the drivers that are certainly pertinent to the workshop today come into play with sustainability, energy, then life cycle durability, and other aspects of environmental impacts that are especially concerning to us, both for the safety of our soldiers and the sustainability and reliability of training ranges and other things on our installations to serve operational needs of the military. So I don't have a lot of fancy charts in here. I figured I've sat in on a couple of these other workshops, and these have been great, I think, working meetings and discussions. Whoops, I don't know why those are advancing. So I thought I'd put out some talking points on, where we are and where we're going. And the Corps is a little bit unique in the DoD in that we have, two hats. We serve a military hat that, the folks in the DoD are well aware of, but we also serve the civil works needs of the nation and, something that probably most of the general public thinks of when they think of the Corps of Engineers. And the drivers there are very different. And, I'm just being honest here, not putting out a position of leadership, but we also have a lack of drivers, I think, particularly when it comes to sustainability and climate change. But there's a lot of things that we are doing and have been doing that do address some of those challenges. I think in the prior discussion brought out all of these new material technologies, which are really exciting for the construction industry. But when we look across our mission in civil works, we are largely driven by the burden of aging infrastructure. Right? We are building new projects. We're, responding and adapting after natural disasters. But the biggest burden that we have in our portfolio economically and when it comes to operations and maintenance is our aging infrastructure portfolio. And so, the driver there that we think is critical from a sustainability perspective is extending those service lives, taking that embodied energy in those projects, which are massive uses of concrete and steel, and extending the service life of those projects as long as we can. And so we're doing that with, a variety of innovative technologies, service life modeling approaches, and all of that feeds into more rigorous and optimized asset management approaches. There are also a lot of things that I see in how, in particular, the Corps of Engineers and some of our interagency partners have functioned in the past, and things that we've integrated into our projects that, when you look at them with the lens of sustainability, are good, right? But we didn't check those boxes because we didn't have boxes to check, right? But we've been using, the example in the previous presentation of things like fly ash and slag, byproduct materials from other manufacturing sectors. The Corps of Engineers has been using those since the 1930s in larger volumes than anybody, right? But we weren't doing it because of sustainability. We were doing it because it gave us unique performance characteristics that were needed in those projects. So, a lot of innovations like that in the past, I think, have provided benefits and continue to in our industry. More optimized design approaches, better use of computational tools is all helping us on the civil side, especially in our military infrastructure, facilities, and installations reap the benefits of that as well. On the military side, I think, especially in the last decade, we have really seen a push towards modernization. I would say, honestly, without much of an eye towards sustainability and climate change. We're more focused on how are we going to adapt to these changing hazards in the future world so that we can fight and win. And so there's really an operational push on what the impacts of these types of things are going to be on our ability to accomplish the mission, right? And so, I'm seeing a growing emphasis on this in everything that we do in sustainability and climate change. But I think it's always going to be in the lens of how it impacts the mission as well. And so, we see a growing emphasis on energy and water security, as well as natural hazards and combinations of hazards that may occur in future operational environments that could impact our ability to project power in fight from a military perspective. But there are many opportunities that we're tracking, I think, especially in the research community, trying to kind of get ahead of requirements and be positioned to lead in some of these areas. And this is even, I would say in the new administration, more active than I was even anticipating. Many of these drivers, which I think in the past were the type of things that, we would put out a policy white paper or a good news story. We're seeing direct upwards and people and money being applied towards climate change and resilience types of objectives in ways that I haven't seen in my career so far. So I think it's very exciting time for this type of activity. Some of the initiatives that we're beginning to develop, some of these we've been working on for a while, but I think we're going to have more top-down support for in the future, is things like nature-based solutions, and I'll show some examples of that, as opposed to hard-built infrastructure, concrete and steel. Are there things that we can do with nature, natural processes, natural materials that can facilitate our engineering mission? Multi-hazard resilience is something we've been focusing on largely from a climate adaptation perspective. But I think we're really going to try to wrap our heads around that more than we ever have in the past, and linking that in beyond the economic impacts, but also the operational impacts, the community resilience impacts. And that's something that, we're concerned with from our mission space, but we're seeing, increasing drivers, especially in our civil works portfolio, where our non-federal sponsors, state and local sponsors of these projects that are oftentimes teaming with the Corps and its federal dollars, they're interested in those types of solutions as well for their communities. Another effort that has been growing, and I think is going to be brought to bear on this problem as well, is really the nexus, what I call the nexus of design, materials, and manufacturing. Right? We often think of those in their individual stovepipes, but in reality, they all function together. And so, how we can bring those together, not just from a performance lens, but say from a embodied energy lens, I think is going to be critical as well. And that plays into materials by design and other material systems. I really like the previous comments about things like cross-laminated timber and various advancements in biotechnology. I think that's going to open up a lot of opportunities in the future, as well as manufacturing and construction processes. the materials and their chemistry is one part of the solution, but a lot of the issues come upstream of the materials and design themselves. It's in the manufacturing process. I wanted to highlight, these are kind of my collection of thoughts from a few of our senior leaders and folks I interact with in this community. But what are some of the particular considerations in the construction materials and construction industry that we see as the big challenges and the big opportunities to work towards? A lot of the large drivers, of course, in the materials area are things like cement, right? As noted as one of the largest producers of CO2 emissions of all manufacturing. And there's a lot of advancements going on there that we'll talk a little bit about. But just general construction practices they're very high energy manufacturing processes. One thing I like to highlight, and I think your comment, Julie, about this is very different than software or an iPhone. And when I sit in workshops with this kind of a focus, I like to reiterate that most of our construction materials rely on commodity type products, right? And so it's very challenging to us from a government perspective when we have all of these new materials and all of these new, let's say, cementing chemistries. It's very challenging to us that they're all being developed by different, small and large businesses with no standards, and everybody says that theirs is better than everybody else's, right? So from a government perspective, that's challenging, and it's particularly challenging on the construction industry that relies on commodity products that are consistent and standardized anywhere you go, almost anywhere you go in the world. The other drivers of the construction materials are cheap, right? So I think that's one of the big things that drives everything that we do. And that the construction industry does is that, often from a sustainability perspective, it's easier to buy down risk or reduce the cost associated with design and construction by using more materials or materials that are less green or gain strength faster. And that's because there really is in most cases, no economic advantage because we're driven by cost and performance. And so, I think really to generate action in this area, you either need economic drivers that facilitate that change, or you need policy drivers. And I think the policy drivers are on the way. We have used the economic drivers to our advantage, like I mentioned in the past, where we're thinking about life cycle, operations and maintenance cost, and that may drive us to use something that's more durable and extends that embodied energy over a longer service life. My next point here, we've got to think beyond steel and concrete. We are not doing enough with cross-laminated timber and other kinds of construction materials. That's going to be something that I think we need to integrate more as an option, putting those types of things on the menu with the policy that makes people think about and track metrics associated with sustainability. The other thing is life cycle, thinking full life cycle of projects. We've had initiatives in 100-year service lives for capital infrastructure projects for quite some time, but they're all basically based on economic drivers. And so I think we need to integrate that as well as reducing the risk that I think the construction industry is very reactive to when they're doing design and selecting materials. And so the example that I'll give you on the right, just as a little cartoon example of what we see day in and day out in our design build projects is we may have an engineer designing for 4,500 psi concrete, say very typical construction grade type of material. We have uncertainty in those materials and uncertainties in construction processes, so we will automatically add a 20% safety factor on top of that to account for that. Then that goes to a contractor who identifies that they want to buy down the risk associated with not meeting that requirement, and they want to do it faster. So they bump their requirements up even further. and that goes to a concrete supplier that wants to make sure that they always meet the requirements placed on them by the contractor, and they bump the strength up even further. And when you're doing that, you're adding additional cement and things to that concrete mixture proportion that is making it more costly, but it's also increasing the embodied energy as well. Just as one example. And the last example I have down here on the bottom is another talking point I like to bring up in these kind of discussions is, the construction industry, I think, is a lot more complicated, and there's a lot more moving parts that all have to be holding hands to, I think, innovate in this area. So it's not just, researchers, engineers, and manufacturers. You've got policy people that are providing the funding and direction for these projects. You've got academics that are training the next generation of our engineers to design these projects. You've got contractors that have a whole series of drivers that they face, and you've got a blue-collar labor workforce. I don't think we're all going to be replaced by robots anytime soon, and so they've got to be on board with this too. And so there's a lot of moving parts, and we often, check the box on a couple of these, but we don't really think holistically about how we're going to educate and move forward across the entire industry. I'll just flip here through a few examples really quickly of different things that we're doing. We've been working with Portland limestone cements for a long time. They do have a marginal to pretty moderate reduction in carbon emissions associated with them. They're incorporated in all of our standards, and they're used pervasively across the Corps of Engineers now. And that's largely reacting to industry, as a lot of industry has switched to these materials. We're also working in alternative cementing chemistries, both on the civil and the military side, and we've actually been doing that for about a decade before these materials maybe had much interest from a sustainability perspective, because they also offer some very unique performance advantages. So Portland lime, this is kind of acronym soup here, but Portland limestone cements, calcium sulfoaluminate cements, LC3, the limestone calcine clay cements, and some of the carbonating cement chemistries. All things that we're very interested in, especially if these are becoming more available, more standardized. We want to be thinking about how do we modernize our specifications and guidance and design procedures to accept those types of materials. And we've been working with other agencies. I pulled this graphic from a project that we recently finished with the Federal Highway Administration and some academic and industry partners, investigating these, developing new design procedures, doing field durability and demonstration studies. And it's all really, I think, very promising. But along with these changes in cement chemistries, where we're largely reducing the amount of calcium oxide in these, because that's the main driver of CO2 emissions, is that we're calcining limestone. And so the more we can reduce the calcium content, the better we get. But that comes along with manufacturing innovations. What types of fuels is the cement industry using for their kilns? Grinding energy associated with grinding the cement down to the appropriate particle sizes is another big source of energy footprint. We're really embracing construction materials by design. This is just kind of an example of some of the different efforts. This is actually in one of my programs here at ERDIC. Looking at wherever we go, how do we come up with the most optimized material solution based on locally available materials and specific performance requirements. So we're not using, somewhat antiquated and extremely conservative design procedures. We're getting down to a more engineered solution. And so this is a combination of materials and processing simulations, as well as solid mechanics simulations that feed into the types of design tools that we're using to design new types of infrastructure projects. Another really interesting area that we see a lot of value in, and we're really embracing in the Corps of Engineers, is nature-based solutions. I'll tell you just anecdotally, our Chief of Engineers, Commanding General, came to visit us a couple of weeks ago, And the first question that the transition team for the new administration asked him is, why isn't the Corps of Engineers doing more engineering with nature-based solutions projects? So this is definitely a driver going forward for the things that we're doing. We're really, as opposed to, say, when we're delivering a flood risk mitigation project, as opposed to building a 10-foot tall seawall, can we do that with a combination of wetlands and dunes and mangroves, for example? Or as opposed to doing a conventional beach renourishment project, can we intelligently place sediment offshore by our understanding of hydrodynamic phenomena that basically automatically utilizes a natural process to do what would require extensive construction materials and equipment to achieve? And so this Engineering with Nature initiative is I think, really moving in that direction, and we're going to see growth in that in the future. As I mentioned, we still have significant challenges with aging infrastructure. That's the big drivers that we have both on the military and especially the civil side. And so, we're always interested in solutions that help us better understand what's going on in those projects, how we can predict their future performance and maintain them and extend service lives. Which also has, I think, sustainability benefits over just, reconstructing that infrastructure. And the final focus, before I turn it over to my colleague, Eric, is in advanced manufacturing. We are, within the Army, ERDIC is I would say, not really at the tip of the spear on a lot of manufacturing science innovation, but we're looking at unique applications of advanced manufacturing technology within our mission space. But some of the particular advancements you'll see here is in additive construction technology. We have interest in environmental sustainability of things like additive manufacturing, new materials that it allows us to produce that can provide significant improvements over conventional manufacturing processes. And as I mentioned, the kind of nexus between design, materials, and manufacturing, and a lot of that is enabled by our leadership in high-performance computing, modeling, and simulation capabilities. So I'll pass it over to my colleague who's on the line as well, Eric Kreiger, and he's going to give a quick overview. I know, Henry, you were especially interested in some of the additive construction type of work, so he's going to talk briefly about some of the things we're doing there.
So one of the areas that we're advancing is 3D printing with concrete materials for construction, large-scale construction 3D printing, which we call additive construction. So essentially, why we're looking at that as a part of the DoD is expeditionary structures are labor-intensive. They require a large amount of manpower, energy expensive, and material expensive. So our solution to that, because we want to deploy to a local area and utilize the materials there, is we 3D print custom designed expeditionary structures on demand in the field using locally available materials. The impact of this is, which we've shown, we have some publications out there which show we can save time, we can save money, save material, save energy and fuel, and reduction in hard labor and manpower because we're using a printer, and we're also eliminating formwork and improve protection. So typically with these structures, and we focus primarily on concrete, Portland cement-based concrete, but we have done several different items: a bridge, 2 buildings, as well as different infrastructure applications such as Jersey barriers, T-walls, and fighting positions. If you can advance the next slide, Robert. So in focusing on sustainability, we're reducing concrete materials, reinforcement materials through optimization. So because we're doing an additive construction or a 3D printing process, we can now, in our CAD model, design where we want the material to go, and we can place that material. And our only limitation is on the properties of that material. We have reduced logistics, and then removal of formwork. So that reduces time, logistics, and cost. Improved energy performance, which I'll show on the next slide. And then we're also looking at alternative materials for this process. So we focus primarily on Portland cement. We are looking at alternative cements. In particular, we've looked at geopolymers, low conductivity aggregates to reduce conductivity in that of our specimens if we're using it in a wall. Supplementary cementitious materials, we use fly ash and silica fume in some of our mixes, as well as we're interested in looking at others. Polymer concretes, metals, and polymers are some of the alternatives to cements that we are looking at. There's a image of analysis we did of the comparison between additively constructed concrete, which is ACC, or reinforced additively constructed concrete, which is RACC, in comparison to CMU and traditional cast concrete. And so we have a reduction in that cost primarily because we're eliminating formwork, we're eliminating the need to place blocks over a long period of time. And so that's the primary reason for that reduction in cost. But then we also have adding that into the ability to optimize the shape. Then we can also improve the structural performance as well as the use of materials. If you can advance the slide. So finishing up here, kind of highlighting energy performance. So one thing that our construction engineering research laboratory is well versed in is energy performance and energy usage. So one thing that we've particularly looked at for this is comparing a 3D printed concrete wall to a CMU wall. And we're in the process of looking at thermal conductivity and things and actual testing of this of these applications. So in terms of energy performance, we've done energy and thermal modeling, thermal testing. We can design these to improve the energy performance through the geometry. But one thing to note is that it's comparable or better. We can make it comparable or better to CMU construction, and with reduced embodied energy through the placement of materials. And then that's again optimized material usage. So that's the in terms of additive construction, those are the highlights in relation to sustainability. So thank you.